x plus 9/4. I have a hard time saying fifth, the th. Half my front tooth is fake. So, looks really cool in black light. And that's not one of those BS stories. That's a real story. That's true. No, it's all epoxied together. No, I can't just go. I could, but I'd have to use my 8-iron to death back there. So, and this is a true story. Yes. I was in. What was it? I want to say it was first grade. I was still living in Chicago, and I was at St. Alphonsus School where I went to school, and they had giant metal railings on the stairwells, and I thought it was really cool to go down the stairs real fast and try to slide, and I went right into my face right into the railing.
You already have that.
Yeah, well, it was first grade. So I had that tooth already, and then over the course of however many years, it's broken a couple times. But so far, this one's lasted me about 20 years. Did I? Yeah. Yeah, they were able to put it over because there was just enough of it on that side. It was mainly broken in the back. But yeah, it's good times. And that's a true story. It's not one of those 80-20. It's not the 20. It's an 81 story. You guys are like, wow. Thank you, Murphy. Thank you very much. But yeah, it does look pretty cool in black light because it's just black. Yeah, I want to call it. I got black lights in the room because I'm 12. And then lastly, I'm going to add 2 over. But instead of adding 2, I'm going to add it as a fraction. What fraction am I going to add over? 8/4, good. 8/4. You're like, oh, it's 2/1. Yeah, it is. But how about adding 8/4? Because we're going to have it in terms of 4s. So we have it as, that would be what? 17/4. Hopefully I did that correct. And then one last couple with the parallels and perpendiculars. When you're doing parallels and perpendiculars, really the main thing is to always go back and read what part they're asking you to do. More often than not, if you do a couple of parallel problems right away, you forget to read the next one says perpendicular, you do parallel again. I see it all the time. Just that's why I always say, is it a parallel or perpendicular problem when you're doing it? Just so you catch yourself before you go too fast. So let's see here. I'm going to do 24. This one says 3, -5, and it wants to be parallel to y equals 0. Parallel to y equals 0. Oh yeah, horizontal.
I don't get it.
What? The horizontal joke?
Yeah.
Okay. So, all right. No. It's okay. So, y equals 0. We talked about this yesterday, and I know I flew through it. Okay. When you have y equals 0, or y equals any number whatsoever, that means that on a graph. Oh, where's my graph? On a graph, that y value remains constant. No matter what the x value is, the y is always going to be the same. So as I go through, there y equals 3, no matter what. Okay. Is that a horizontal or a vertical line? It's horizontal. Okay. Y equals a number is always a horizontal line. Okay. The slope of every horizontal line is always going to be 0. Okay. The slope of every horizontal line is always 0. Parallel to every horizontal line is always going to be another horizontal line. Remember how we talked about the saw her notebook yesterday? All those little blue lines going across are always horizontal, unless you're this way, but then you get right this way. Thank you. So you're always going across, and every one of those, think of this one in the middle as 0. Here's 1, 2, 3, like y equals 1, 2, 3, negative 1, negative 2, and so on and so on. So no matter what, every single horizontal line will always be parallel. So y equals a number is always parallel to some other y equals a number. In that ordered pair they gave us, well, the one that we started, the one we started with was the line at y equals 0. The ordered pair was, bless you, was at 3, negative 5. What line goes through that would be parallel to at y equals 0? Y equals negative 5. And that's where that little shortcut comes into play. That's where that comes into play. Yes, sir?
Oh, wait, never mind.
Great question. Bless you. Sorry you're allergic to math. Does that help a little bit? And the dumb thing of me saying like horizontal being the O because the slope is 0.
Oh, it's 0, y.
Okay. Yes, sir.
So it's parallel to x equals 0.
No. Hey guys, this is a great question. It's if there was a, let me pull back up the graph real quick. What Grayson was asking was, what happens when it's x equals 0? X equals 0 is a vertical line. So if I put in a vertical line at x equals 0, it's an undefined slope, but what other lines have undefined slopes? All vertical lines have undefined slopes. So that means that anytime you have an x equaling some number, it's always going to be parallel to an equation of x equals a number, no matter what. So whatever ordered pair, if I say that our ordered pair is over here, that ordered pair is at what, negative 4 and 3? The x coordinate there is negative 4. So x equaling negative 4 would be the parallel line to it. Oops. Okay. And that would be its parallel line. If I wanted to be vertical to it, perpendicular. Vocab, I'm forgetting how to do math, it's only been a few days. If I wanted to be perpendicular to a vertical line, horizontal lines are perpendicular to vertical lines. And that's where those things change up, the x's and y's. Right? And that's how that goes. Right? And yes, it's the dumb trick about the O in horizontal being the slope of 0. And I think with this example, it's starting with the line at y equals 0, kind of throws people off. If it was y equals 6, and I said what's parallel to that after this point, you would say, oh, it's just at 1. It's just at 0. So if you were going to do one that actually had a little bit of work to it, for example, let's see, this one is through the ordered pair 0, 1, and it's parallel to the equation y equals 1/4 x plus 2. First thing it'll say, I'll ask you guys, is what is the original slope? 1/4, okay? And then I'll ask, is this a parallel or a perpendicular problem? And how do you know it's parallel? Because it says so, okay? So what is parallel to 1/4? 1/4. And then I use my newfound slope with the given point, and I use point slope formula to solve it. And it's all right. And I figured it's going to take a day to remember all this stuff. It's no big deal. Oops. There's one thing that you might have recognized with the ordered pair. The ordered pair is at 0, 1. Where is that on a graph?
On the y.
Y-intercept, very good. So would you have to have used point slope if you knew that that's the y-intercept?
No.
If you caught it, great. If not, you would have just done, oh wait, this is 1/4 x, add the 1 over, and you would have gotten it anyway. But sometimes if you recognize those little tricks quicker, it just saves you a little bit of time. It's not the end of the world if you don't see it, okay? It really isn't. Because the algebra of this, by just moving that value over, will get you there. Okay? It'll get you there. Only thing that changes when you have perpendicular then is what? Slopes. Yeah, good. So if I want to be perpendicular, I'm going to try the other one here where it's 3, -5, perpendicular to if I do one like that, first thing I gotta do is figure out what's my original slope. 3/4. Is this a parallel or a perpendicular problem? Because it says
Perpendicular.
I know, right? What is the perpendicular slope of 3/4? Four threes? Yes, those two. Wouldn't 4 3s be 12?
What?
He said 4 3s. I said, wouldn't that be 12? Did you need a calculator for that one? All right, just check it. And then I go back in here, y by +5, -4/3, x minus 3. It's nice when they give you fractions that wind up cleaning themselves up rather quickly when you distribute it in. So here you wind up with what? Y +5, -4/3, x +4, subtract 5. Let me get that. You okay with that? Good deal. All right, so let's talk a little bit real quick about then, why do we like standard form? Why do I like standard form? So one of the things that happens within standard form, excuse me, this isn't on that sheet that I gave you guys, so just so you guys know, when you have standard form, there's a couple of things that it's going to allow us to do. For example, and this will help us get to what we're going to do tomorrow a little bit with what like I said, we're going to bring up the quick graphs to tomorrow, and then we'll probably do some absolute value stuff on Friday. What's nice about standard form is that it allows us to graph things really, really fast. Let me ask you this. Do you remember how many points you need to have to determine a line? 2, very good. Now, when you have something like this, let me see here, let's back up. I would give you guys some graph paper for a few of these things, but unfortunately, I don't think there's a single copy machine in this building right now that works at all. So it's great. It's making things really easy for a lot of stuff right now. It is. Let me ask you this, and this really doesn't have to do with this format here, but as I'm just drawing a graph, as I cross the y-intercept, what's my value of x? 0, very good. As I cross my x-intercept, what's my value of y? 0. So if I cross, let's see, try. Let's say I have 2x plus 3y equals 6. That looks like standard form, doesn't it? Okay. Now, if I'm trying to figure out where my intercepts are, you guys just said that if my value of x is 0, I can find my y-intercept. And you also said that if I have my value of y being 0, I can find my x-intercept. So if I do some quick substitutions here, what's 2 times 0? 0. What's 6 divided by 3? 2. So if I cover up this and solve for y, what do I get? 2, which is my my y-intercept. If I cover up this by putting in 0 for y, what do I get for x? 3, which is my x-intercept. Did you guys ever learn that?
Yeah.
Okay. I wasn't sure. I know there's been years that people haven't seen that, and there's been years that students have seen that. So and if you forgot it, it's okay. We're going to do this a bunch of times. It's the cover and solve method for intercepts. Now, also, when I do that, if I connect those, what direction is this telling me my slope is? Oops. Is it a positive, negative, 0, or an undefined slope? It's going to be negative. Very good. So you all remember somebody that we know doing this and doing this and doing this and this and trying to be all cool and funny. Anyway, so with just using those values like that, can't I also determine the slope of that line quickly now that I know my 2 intercepts? Because isn't just rise over run? Now, if I count this, how many did I go down?
Negative.
And then I went over. So you're telling me my slope is negative 2/3, right? Okay. Look at that standard form. Look at that standard form and see if you can find a correlation between. What is it?
The 2 and the 3.
You're right. Okay. Very. Okay. Now, can you extrapolate the fact that you see those both those numbers in there?
Not really.
Okay.
I just saw
All right. Now, let's go to this then. If I wanted to get y by itself in this standard form, what's the first thing that I would do with this? I'd subtract. I'm trying to get y by. I'm trying to isolate y, so I'm going to subtract over. Are you okay with that? All right. So if I do that, I get b times y. Now remember, a, b, and c are constants. X and y are my variables. Okay. So in that formula, there are 2 and 3 and 6 are the a, b, and c respectively. So I have b times y is going to equal negative a times x plus c. Now what do I do? If I want to get y by itself, divided by b. So isn't this now isn't that your slope? Opposite of a over b?
Oh, whoa. Drop the marker.
Thanks. That's whenever we have standard form, it's really, really nice because you can identify the slopes as the opposite of A over B just by manipulating it. Okay? That's a very nice little trick. You're not buying it, are you, Sarah? Why is that? Okay. Remember 10 minutes ago, 12 minutes ago, we did that? And I said get time by itself. And you said, oh, I'll just divide by rate. All we did here is that this equation just has more than one step. By taking, and I have it as 2x plus 3y equaling 6. If I move the 2x over, I get 3y equals negative 2x plus 6. I divide everything by 3. And isn't that my slope? And that's where the A's and B's come into play. Does that help? It's something that you guys probably didn't spend time on, but see why I like standard form? Because not only can you graph really quickly, you can manipulate the stuff to identify slopes and your rate of change is real fast. Right? You can get slopes out of that stuff real quick. There was another one like that I wanted to do. this. What's my slope?
Okay, I try my
Is it positive or negative? Which is it? And that's why. And then see where they get positive out of that. All right. So remember, it's the opposite of A over B. What's your A? Your A value here is 5. Your B value is -6. Your C value is -2. The opposite of +5 is -5. Your B value is -6. That's what that is. Look at he's throwing down back there. Yeah, you're right. So you take that. You suck at that. All right. The idea here is that we can quickly do things. Okay. Same idea. What's nice when, obviously, if we had to graph something like this, let's move this over real quick. Eventually, we might have to figure out how do we graph funky numbers, and it's okay. Because there are times that I don't think we really need to have to worry about graph paper. We can all kind of fudge a graph a little bit, get a rough sketch. So if you go back to the idea of cover and solve here, and like I said, we'll do a lot more of the cover solve stuff tomorrow. If I want to get my y-intercept, I put 0 in for x. So what's -2 divided by -6? Is it positive or negative? 1/3, right? So I can say there's 1/3. Does it matter where I say it is? Nope. Then I do the same idea here. My x-intercept would be at -2/5. Here-ish. And 2 points determine the line. And that's a constant slope. Wow. Good times, huh? I was busy cutting up my flex passes and I did not put in the PDF file, but I will redo the PDF file on today's date, but it's going to be in section 2.4. And it's a couple of things like this, and it's write the equations, and there wasn't really anything in the standard form stuff, but I wanted this perfect time to show you guys this so we can do it tomorrow more. But yeah, it'll be on page 95, so let's see, this is 2.4. I'm giving you one that you kind of have to try to work yourself through as far as how to write an equation given a bunch of information. I don't foresee it being a very difficult task, but I think it'd be a good one for you guys to give it a shot. Okay. The stuff that's in here, like I said, is just, again, write the equation of the line given a couple of points, write the equation of the line that has parallels and perpendiculars. I think this will identify some slope stuff. And then we will get back more into standard form fun tomorrow. All right? We'll get into a lot of standard form fun tomorrow. I will put the PDF on the calendar right now.
Yeah.